Hello guys, welcome back. So in this lecture 2, uh, we are going to talk about adapter containers. Okay, so what are the various types of adapter containers and how do we use them when we talk about STL? Okay, so yeah, so let's just start with the classification. So the first container adapter that we are going to talk about is going to be stack. Okay, it is also a type of data structure. Okay, so we'll talk about it by taking an example and which would clear all the doubts. Okay, then we are going to talk about queue, and then finally we are going to talk about priority queue. Okay, priority queue. Okay, we also call it heap. Okay, we also call it heap data structure. Okay, heap data structure. Okay, all of these are data structures. They store the data in one form or another. Okay, so let's talk about the stack first. Okay, let's talk about the stack. Okay, now how the stack looks like. Okay, so if you have ever went on a in a marriage party, you would have seen that the plates are kept one above the other. Okay, so the plates are stacked this way. This is the first plate, this is the second plate, this is the third plate, this is the fourth plate, this is the fifth plate, this is the sixth plate, and this is the seventh plate. Okay, so in this way the plates are stacked. Okay, this is what we call it, this is what we call as stack. Okay, so yeah, so what happens is it follows LIFO property. Okay, so stack works by following the LIFO property. LIFO means last in first out. Okay, last in first out. Okay, what does it mean? What does the last in first out mean? Okay, now let's see. Okay, so when we put the plates, okay, we put one plate, then we put other plate over the first plate, then the third plate, then fourth, then fifth, then sixth, the seventh. Okay, so when we put the plate that we put at the end, or that at the last, is the first that we are going to pick. Okay, uh, to have some food. Okay, so the plate that we put at the last, okay, in the stack, is going to be the first that is going to be out of the stack. Okay, so this is what we call as LIFO property. Okay, so in context of data, okay, so in context of data, let's say we create a stack and we push some element into it. Okay, let's say this is the stack, and let's say there are some elements. Let's say 11, 5, 6 and 7. We pushed some elements into the stack. Now the element that we pushed at the end, okay, which is 7, is going to be the first that is going to be popped out of the stack. Okay, so if we pop an element of the stack, we are going to get 7 first, then we are going to get 6, then we are going to get 5, and then we are going to get 11. Okay, this is what stack okay, this is how stack works. Okay, now the functions that we can use to access the top element, this is the top element, right? Can is s, let's suppose s is the name of the stack, so s dot top. Okay, this will give us the top element. Okay, so 7 is the top element, so it will give us 7. Okay, now to remove this element, top element, we will use pop function. So let's say s is the stack, s dot pop. Okay, it pops the top element of the stack. So now when we uh, call this function, we are left with only three elements, which are 11, 5 and 6. Okay, 7 gets popped out. Okay, so we are left with these three elements. Okay, now let's see what are the different functions that we can use with the stack. Okay, and how we work with stack. So let's create another function. So let's say we create the function stack.cpp. Okay, now to create the stack function, okay, let me add a new page. To use the stack, okay, we'll have to include its library in which it is defined. Okay, so has include stack at the top. Okay, this is what we need to include. And the syntax of stack, okay, syntax of initializing stack is going to be something like this. We write the stack. Okay, then we give the type. The type can be int, it can be string as well. Okay, in the case where the type is string, we'll store some strings into it. Okay, let's say this is a stack of type string. Let's say we store two strings. Let's say the strings are the name of countries, so USA and India. Let's say we store the uh, you know strings this way. Okay, but in the case of in the case of in the case of integers, we are going to store integers into it. Okay, so let's say I define stack as s. Okay, now let's get back to the Visual Studio Code and let's see how we work with stack. Okay, so let's write the boilerplate code. Okay, okay. Okay, so let's include the library. Okay, yeah, so we are done. Now let's try to initialize the stack. Okay, so stack int, okay, s, to create a stack which will store int values, okay, or integer values. So let's push some elements into it. S dot push, to push the element we'll use push and we'll give the element. Let's say I want to push 1. Okay, let's say similarly I want to push some more elements. Okay, let's say at the second place I want to push 3, at the third place I want to push 4, at the fourth place I want to push 11. Okay, now how this stacks look like, this stack looks like. Okay, so let's get back. So I pushed 4 elements, right? I pushed 1, 3, 4 and 11. So let's get back. Okay, now the stack will look something like this. Okay, this is the stack. Okay, there will be 4 memory locations. Now here 1, because we have pushed it at the first, it will be at the bottommost in the stack. Okay, then 3, then 4 and then 11. The stack will look something like this. Okay, yeah, the stack will look something like this. And now if we try to pop the element, so 11 get popped at first. Okay, so 11, then 4 gets popped. Okay, so 4, then 3 gets popped, so 3, and then 1 gets popped at the last. Okay, this is what we call as the LIFO property. So the last thing that enters is the first which is going to be out. So 11 is the last thing we entered, so it is going to be the first that is going to be out of the stack when we pop the elements. Okay, now let's see how it works. So for int x belongs to stack, so name of the stack is s, right? Okay, we, for auto it should be I don't know why, what is wrong with this. Okay, so we don't use for loop here, we use while. Okay, while not stack dot empty. Okay, s, so name of the stack is s. Okay, what dot empty function, what empty function does is that it checks whether s is empty or not. So in this case there are 4 elements in the stack, right? Stack looks like this, so it is not empty. So while it is not empty, okay, till the time it is not empty, so what I'm doing is I'm using while loop here. Okay, while not empty, what I'm doing, I'm printing the element which is at the top. Okay, s dot top. Okay, to access the top element, right? Let's put some space as well after this, so that it prints by having spaces in between. Okay, and having places in between, yeah. So and then what we do is we pop that element. Okay, we print that element and then we pop that element, so that next time we print the next element. Okay, so s dot pop, to pop the element. So what happens inside this, first it checks whether s is empty or not. If not empty, okay, this is exclamation, this exclamation represents whether it is empty or not, sorry, whether it is not empty. Okay, so this represent not, and s dot empty represents whether it is empty or not. Okay, so if not empty, okay, this represents not. Okay, this symbol. So when till the time the stack is not empty, it will print the top element. Okay, and then it will pop the top element as well. So first it prints 11, then it pops 11. So 4 is the top element now. So then it prints 4, then it pops 4. Okay, so now 3 is the top element, so it prints 3, then it pops 3 as well. Now only 1 is the top element, so it prints 1 and then it pops 1. So now after this, okay, after this thing, if we try to print uh, stack size, okay, we have a size function as well to check the size of the stack. uh, it would give us 0 as the output because all the elements have been popped out of the stack. Okay, now let's check. So while stack is not empty, what we'll do, we'll print the top element. Okay, by giving some space after that. Okay, and then we will pop the top element. Okay, yeah. So let's see what is the output. The output should be 11 4 3 and 3 and 1. Yeah, so output is 11 4 3 and 1. Okay, now if we try to find the, okay, if we try to find the size, okay, after popping these elements, let's not print these elements, okay, let's just, let's see the size of the element, stack after popping. Okay, s dot size. Okay, now all the elements have been popped, so the size should be 0. Okay, yeah, so now if we check if stack is empty or not, it would give us 1 as the output. Okay, because the stack is empty now. Okay, let's see. Yeah, so in the first line it gives us whether the size of the stack, which is 0 obviously, and in the second case it checks whether the stack is empty or not. Since the stack is empty, it gives us the boolean 1. Okay, yeah, so this was all about the stack. Now let's talk about queue. Okay, so queue is the second type of container adapters. Okay, queue. Okay, so what is this queue? Okay, when we talk about queue is something, you have heard of a queue, right? When, let's suppose this is a shop. Okay, and there are some, you know customers. Okay, so they are at a distance with each other. Okay, so this is the first customer, this is the second customer, and then this is the third customer, this is the fourth customer. Okay, this is the fourth customer, and let's say this is the sorry, okay, this is the fifth customer. Okay, so there are 5 customers, right? So this is what we call a queue. Okay, so this is a queue, and the queue is also a data structure. So we must remember, this is a node. Okay, it follows FIFO property. Okay, FIFO property, you must note this. Okay, what is FIFO property now? FIFO means first in, first out. Okay, so the customer which has entered first in the queue is going to be the first that is going to be served by this shop, and then it is going to be out of the queue. Okay, so the first customer, he gets served by the shop whatever he needs, and then he gets out of the queue, and then second customer, and then third customer, and then fourth customer, and then fifth customer. This is the order in which they get served. So this is what we call FIFO property. Okay, now in queue we can access the first element using front. Okay, front function, we can use the size function to know if the size of the queue, what is the size of the queue, and we can use empty function as well. Okay, empty function, to know whether the queue is empty or not. Okay, now let's get back to the Visual Studio Code and let's see how it works. Okay, so one thing I forgot to tell is that the syntax of denoting a queue. So we write queue, then we give the data type. Here we'll write the data type. Let's say I define it as type int, so int, and then let's say queue is the name. Okay, this is the name of the queue. You can name it anything, but there shouldn't be spaces in between. Okay, let's get back to the Visual Studio Code. Let's try to work with queue. Okay, let's create another program. .cpp. Okay, so let's remove this. Okay, let's write the boilerplate code. Okay, yeah, okay, so let's just include the library. So library of queue is has include queue. Okay, this is how we include the library. Now we can work with queue. So let's create a queue of, let's say we create a queue of type string now. Okay, queue, same way we just change the data type. Okay, now let's say there are 3 customers. Okay, let's push the customers into the queue. Okay, let's say the first customer is me myself. Okay, Priyansh. Okay, then the second customer, let's say, okay, likewise there are, let's say, 5 customers. So the second one is John, the third one is Thomas Selby. Okay, the fourth customer is let's say uh, Iron Man. Okay, and let's say the fifth customer is Batman. Okay, let's say these are the 5 customers. Now how do we print the queue? We can print it using for loop only. Okay, for auto x belongs to uh, queue cout. uh, okay, so okay, we again use the while loop only, while not queue dot empty. Okay, we can pop the first element of the queue. We can access, and we can pop the first element. So to pop the first element, we'll use queue dot pop. First we print the first element, queue dot front, okay, using the front function. Okay, and then we leave the space so that all the elements are distinct. Okay, so then we pop the first element, q dot pop. Okay, this is how we print the element in the sequence. Okay, q. So the first element that I pushed into the queue is Priyansh, so we'll get first customer as Priyansh only. Let's try to print the output. So the output will be, should be the same way. Okay, should be in the same way. Yeah, so first is Priyansh, then second is John, and third is, let's say I put underscore here so that we know. Okay, so Thomas Selby. Fourth is, let's say I put again underscore here, let's say. Yeah, so this is first, this is second, this is third, this is fourth, and this is fifth. Batman is fifth. Okay, yeah, so this is how queues work. Okay, now let's talk about the priority queues. Okay, which are, okay, which are the last uh, in the adapter containers. Okay, let's talk about the priority queues. Let's get to the next page. So what are priority queues? Okay, last one is priority queues. Okay, queues. So priority queues are the data structures. Okay, they are also called heaps. Okay, they store the data. A default priority queue is a max heap. Okay, max heap. So when we push some elements into this queue, okay, let's say we push uh, 1 2 3 4 5, okay, these elements into the queue. So priority queue. So how the priority queue looks? So the maximum element comes first. Okay, so 5 will come first, then 4, then 3, then 2, and then 1. Okay, so in this way, you know uh, the elements will be stored inside the priority queue. To push the element, we use push. Okay, push function inside. Okay, let me erase this. Okay, let's erase all of this. Okay, so to push the element, we use push function, push, and then we give the element that we want to push inside the queue. Okay, priority queue, sorry. To pop, we use pop function. Okay, to check if empty or not, we use empty function. Okay, to access the first element, we use top again, as in the case of stack. So top function. Okay, so yeah, these are the functions that we work with, that we have to know while working with priority queues. Now let's try to work with priority queues. So how do we, I forgot to tell you one thing. What is the syntax? Okay, so yeah, so syntax of initializing a max heap. Okay, there are two types of heaps. One is the max heap. Okay, max heap. In max heap, the max element will be at the front, and the elements are stored in the descending order. Another one is the min heap. Okay, which stores the element in this order: first the smallest element, and at the end it will the element at the end will be the largest. Okay, it is min heap stores the element in the ascending order, while max heap stores element in the descending order. Now how do we create the max heap and min heap? Okay, let me go to the next page. Okay, so syntax is, okay, for max heap the syntax is going to be simple. uh, So for max heap, the syntax is going to be priority queue, since it is a priority queue, right? We call it max heap, but we this is priority queue only. Priority queue of, let's say, data type int, okay, and pq, let's say we call it. So this is an example of max heap. We have initialized the max heap. So this pq will store the elements in the descending order. Descending order, okay, order. Now second one is min heap. Min heap. Okay. So what is the syntax of the min heap? Let's say I create a priority queue. Priority queue. Okay. Int we write vector of int, okay, and then we give greater of int, okay, pq, okay. This is how we create min heap, okay. This is only how we create. If you're finding it complex, just try to learn this, okay. It is very simple. You just have to remember this, that's it, okay. Then we can work with min heap and max heap. Now to, you know, to work with priority queues, we have to include this library, okay. We have to include priority queue library, okay, at the top of the C++ function. This is what we have to do, okay. Now let's get back to the Visual Studio Code and let's see how it works, okay. So yeah, so let's create another, okay, priority queue dot cpp, okay. So let's say I created, so let's write the boilerplate code, okay. Yeah, so now let's include the library, okay. Let's say the library is priority queue, right? Yeah. What is wrong with the library? Okay. Include, hash include. Still it gives error. Let's see. If it is wrong or not. Uh, priority queue. What is wrong? So I'm getting error. Let me run the program. Okay. Let's run the program now. Still getting an error. No such file in the directory. Why is it so? Okay. So let's try to include this again. Okay. I think it is a kind of bug or something. So it is not working. So we'll include another library, okay. It has all the STL things in it, okay. Yeah, now it won't give any error. So don't mind if you don't know about this. It is just a library, okay, which has every library inside it. So now we have created a max heap, okay. This is a max heap, okay, max heap. The elements, uh, the elements are going to be stored uh, in the descending order, okay, descending order. Let's see by pushing some elements. Pq dot push, okay, we push the elements by using push function, okay. Let's say I want to push one here, okay. Okay, I just put up, you know, push the elements opposite, okay. Let's say I push then 4 here, uh, minus 5, okay, then 11, then let's say I put push 21, okay. So the elements that I'll get in the priority queue will have order 21, 11, 4, 1 and minus 5, okay. Let's try to print the order, okay. So for, okay, for uh, let's say uh, yeah, so how do we print the element in the priority queue? Simply what we can do here is that we can use the size function to get the size of the priority key, okay, pq dot size, okay, this way. And now we can use for loop. For int I equals to 0, I is less than n, okay, I plus plus, each time we increment I, okay. So the loop will run n times, okay, 0 to n, right, less than n. So it will run n times because one time it runs at the 0 only, at the value of I as 0, okay. So we'll print uh, the first element by using pq.top. Okay, top. This helps to print the first element, the element which is present at the front of the priority queue, okay, or at the top of the priority queue. Uh, and then we use pop function just as we did in the case of stack to pop the first element. So the order of the elements that we'll get is 21, 11, 4, 1 and -5. Let's see what is the output. Okay, let's try to clear the terminal. Okay, now let's print. Yeah, so the output is 21, 11, 4, 1 and -5. So this is the descending order, right? So the elements are stored in the descending order. Now let's create a min heap. Okay, by default, if we create a priority queue, it is a max heap. To create a min heap, we'll write priority queue. Okay, int, then we'll write vector of int. Okay, vector of int, and then we'll write greater of int. Okay, this way. Okay, let's say we name it min heap only. Yeah, so that we remember. Okay, now let's say I push some elements into min heap. Let's say dot push, let's say I push 21. Okay, let's say the same way I push some more elements, -3. Let's say I push 12. Let's say I push 2, and let's say I push uh, 36. Okay, so what will be the order in which I'll receive the elements? So first I'll get -3, then I'll get 2, then 12, then 21 and then 36 finally. Okay, let's check the output. So int n is equals to, let's store, we'll have to create another variable, right, because n is already used. So m is equals to min heap dot size. Okay, min heap dot size. Okay, now to print the elements for int I equals to 0, I is less than m I plus plus. So loop runs m times. Okay, cout. Okay, to access the front element of the min heap, we'll use min heap dot top. Okay, and we'll give space as well, right? Yeah, and to pop the element from the front, we'll use min heap dot pop. Okay, this pops the first element. Now this way we are going to pop the element. Now let's see what is the output. Okay, let's comment this out. Okay, so we want to print this. We directly print the output of the min heap. Okay, now let's see what we get as the output. Yeah, so we get the smallest element first and then we get the elements larger to it. Okay, so we get the elements in the ascending order. So this is how we work with the max heap and the min heap. So that was it for this lecture. Hope to see you in the next lecture.